So in the session 2, I am going to cover effect of pressure on steam formation and properties of steam. So before going to start this, these are the contents I am going to cover in this session 2. Summary of a previous session means what had covered in the session 1, that we will see once again briefly. The next, effect of pressure on steam formation, then properties of steam, and multiple choice questions on the topics covered in this session. So this formation of steam at constant pressure, this is the topic I had covered in the session 1, and some of the students gave me a feedback. Sir, you had explained completely in English, so we couldn't follow it. So could you please explain me little bit Kannada? So now I'm going to explain the brief about session 1 in Kannada. ಈ ಚಿತ್ರದಲ್ಲಿ ನಾನು ಏನು ತೋರಿಸ್ತಾ ಇದ್ದೇನೆ ಅದನ್ನ ಸೆಷನ್ 1 ಒಳಗಡೆ ನಾನು ಕ್ಲಿಯರ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಅನ್ನ ಮಾಡಿದ್ದೇನೆ. The formation of steam at constant pressure is very important for the exam point of view, and also this is the base for this entire subject, that is applied thermal engineering. ಈ ಎಡಗಡೆಯ ಒಂದು ಚಿತ್ರದಲ್ಲಿ ನಾನು 5 ಸಿಲಿಂಡರ್ ಅನ್ನು ತೋರಿಸ್ತಾ ಇದ್ದೇನೆ. ಆ 5 ಸಿಲಿಂಡರ್ ಸಪರೇಟ್ ಯೂನಿಕ್ ಆಗಿದ್ದಾವೆ. ಆ ಸಿಲಿಂಡರ್ ಅಲ್ಲಿ ನಾನು ಮೊದಲನೇ ಸಿಲಿಂಡರ್ ಅಲ್ಲಿ ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಅಂದ್ರೆ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್ ನ ತಗೋತಾ ಇದ್ದೇನೆ. ಒಂದಿಷ್ಟು ವಾಲ್ಯೂಮ್ ವಾಟರ್ ನ ತಗೋತಾ ಇದ್ದೇನೆ. ಮೀನ್ಸ್ ಪರಿಮಾಣ, ವಾಲ್ಯೂಮ್ ಈಕ್ವಲ್ ಎಸ್ ಪರಿಮಾಣ. ಆ ವಾಟರ್ ನ ತಗೊಂಡ್ಬಿಟ್ಟು ಸೊ ಇದ್ರಲ್ಲಿ ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇರ್ತೀನಿ ಅಂತಂದ್ರೆ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಸ್ಟೀಮ್ ಎಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಮೀನ್ಸ್ ನೀವು ಉಗಿಯನ್ನ ಉತ್ಪಾದನೆ ಮಾಡಬೇಕು. ಉಗಿ ಹೇಗೆ ಉತ್ಪಾದನೆ ಆಗುತ್ತೆ ಅಂತಂದ್ರೆ ನೀರಿಗೆ ನಾವು ಶಾಖವನ್ನ ಕೊಟ್ಟಾಗ ಆ ನೀರು ಉಗಿಯಾಗಿ ರೂಪುಗೊಳ್ಳುತ್ತದೆ ಅನ್ನೋದು ಗೊತ್ತಿದೆ. ಬಟ್ ಅದು ಉಗಿಯಾಗಿ ರೂಪುಗೊಳ್ಬೇಕಾದಾಗ ಅವನು ಒಂದು ಕಂಡೀಷನ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ ಇಲ್ಲಿ, ಏನಂತಂದ್ರೆ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್, ಒತ್ತಡವನ್ನ ಸ್ಥಿರವಾಗಿಟ್ಟುಕೊಂಡು ನೀವು ನೀರಿನಿಂದ ಉಗಿಯನ್ನ ತಯಾರಿಸಬೇಕು, ನೀರಿನಿಂದ ಉಗಿಯನ್ನ ಉತ್ಪಾದನೆ ಮಾಡಬೇಕು. ಹಾಗಿದ್ದಾಗ ಈ ಸ್ಥಿರವಾದಂತ ಒತ್ತಡವನ್ನ ನಾವು ಹೇಗೆ ಮೇಂಟೈನ್ ಮಾಡಬೇಕು? ಅದಕ್ಕೆ ಈ ಪಿಸ್ಟನ್, ಈ ಸಿಲಿಂಡರ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ನೀರನ್ನ ತೆಗೆದುಕೊಂಡು ಆ ನೀರಿನ ಮೇಲೆ ಒಂದು ಪಿಸ್ಟನ್ ಅನ್ನು ಇಟ್ಟು ಪಿಸ್ಟನ್ನ ಮೇಲೆ ಸ್ವಲ್ಪ ತೂಕವನ್ನ ಇರಿಸಿದ್ದೀವಿ. ತೂಕವನ್ನ ಯಾಕೆ ಇಲ್ಲಿ ಇರಿಸ್ತಾ ಇದ್ದೀವಿ ಅಂತಂದ್ರೆ ಆ ತೂಕವನ್ನ ಇರಿಸಿದಾಗ ಸ್ಥಿರವಾದಂತಹ ಒತ್ತಡವನ್ನ ನಾವು ಕಾಯ್ಕೊಳ್ಳಿಕ್ಕೆ ಸಾಧ್ಯವಾಗ್ತದೆ. ಸೊ ಅದೇ ನಮ್ಗಿರೋದು ಮೇನ್ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಸ್ಟೀಮ್ ಎಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಅಂದ್ರೆ ಸ್ಥಿರವಾದಂತಹ ಒತ್ತಡವನ್ನ ನಾವು ಕಾಯ್ಕೋಬೇಕಾಗುತ್ತೆ. ಅದಕ್ಕೆ ನಾನು ಪಿಸ್ಟನ್ ಮೇಲೆ ಒಂದು ಪಿಸ್ಟನ್ ಮೇಲೆ ನಾನು ಒಂದಿಷ್ಟು ತೂಕವನ್ನ ಹಾಕ್ತಾ ಇದ್ದೇನೆ. ಸೊ ಅದು ಹಾಕ್ಬಿಟ್ಟು ನಾನು ಈ ಒಂದು ಸಿಲಿಂಡರ್ಗೆ ಶಾಖವನ್ನ ಕೊಡ್ಲಿಕ್ಕೆ ಪ್ರಾರಂಭಿಸ್ತೇನೆ. ನೀವು ಯಾವಾಗ ಶಾಖವನ್ನ ಕೊಡ್ಲಿಕ್ಕೆ ಪ್ರಾರಂಭಿಸ್ತೀರೋ ಅವಾಗ ಏನಾಗತ್ತಂದ್ರೆ ಕೊಟ್ಟಂತಹ ಶಾಖವು ಆ ನೀರು ಇರ್ತಕ್ಕಂಥದ್ದು ಅದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೋತದೆ. ಸೊ ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಆ ಶಾಖವನ್ನ ಆ ನೀರು ತೆಗೆದುಕೊಂಡಾಗ ಅವಾಗ ಆ ನೀರು ಏನಾಗತ್ತಂದ್ರೆ ಆ ನೀರಿನ ಟೆಂಪರೇಚರ್, ಉಷ್ಣತೆ ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗುತ್ತೆ. ಉಷ್ಣತೆ ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗುತ್ತೆ. ಮತ್ತೆ ಯಾವಾಗ ಉಷ್ಣತೆ ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗ್ತದೋ ಅವಾಗ ನಿಮ್ದ ಒತ್ತಡ ಕೂಡ ಹೆಚ್ಚಾಗ್ಬೇಕು. ಬಟ್ ನಾವೇನ್ ಹೇಳ್ತಾ ಇದೀವಿ, ಸ್ಥಿರವಾದಂತಹ ಒತ್ತಡವನ್ನ ನೀವು ಇಟ್ಕೋಬೇಕಂತ ಹೇಳ್ತೀವಿ. ಸ್ಥಿರವಾದಂತಹ ಒತ್ತಡವನ್ನ ನೀವು ಇಟ್ಕೋಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? ಅವಾಗ ಇದ್ರದ್ದ ಪರಿಮಾಣ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಪರಿಮಾಣ ಬದಲಾವಣೆ ಹೊಂದುತ್ತೆ. ಪರಿಮಾಣ ಮೀನ್ಸ್ ಘನ ಅಳತೆ, ಮೀನ್ಸ್ ವಾಲ್ಯೂಮ್. ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ? ಬದಲಾವಣೆ ಆಗುತ್ತೆ. ವಾಲ್ಯೂಮ್ ಬದಲಾವಣೆ ಆದಾಗ ಮಾತ್ರ ನಾವು ಸ್ಥಿರವಾದಂತಹ ಒತ್ತಡವನ್ನ ನಾವು ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ? ಮೇಂಟೈನ್ ಮಾಡಕ್ ಸಾಧ್ಯವಾಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಈ ಒಂದನೇ ಸಿಲಿಂಡರ್ ಅಲ್ಲಿ ನೋಡಿದಾಗ ನಾವು ನೀರಿಗೆ ಒಂದು ಶಾಖವನ್ನ ಕೊಡ್ತೀವಿ. ಶಾಖವನ್ನ ಕೊಟ್ಟಾಗ ಅದು ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಸ್ಲೋಲಿ ಆಗಿ ಅದು ಫಸ್ಟ್ ನೀರು ಕೊಟ್ಟಂತ ಶಾಖವನ್ನ ತೆಗೆದುಕೊಂಡ ಆದ್ಮೇಲೆ ಅದು ಏನಾಗುತ್ತೆ, ಕುದಿಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಯಾವಾಗ ಕುದಿಯುತ್ತೋ ಸಡನ್ ಪೀರಿಯಡ್ ಆಫ್ ಟೈಮ್ ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಬಾಯ್ಲಿಂಗ್. ಆಫ್ಟರ್ ದಟ್ ದೆನ್ ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಎವಾಪರೇಟಿಂಗ್. ಅವಾಗ ಎವಾಪರೇಷನ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಆವಾಗ ಈ ಮೂರನೇ ಒಂದು ಚಿತ್ರದಲ್ಲಿ ನಾನು ತೋರಿಸಿದ್ದೀನಿ. ಕೆಳಗಡೆ ಇಲ್ಲಿ ಒಂದನೇ ಚಿತ್ರದಲ್ಲಿ ಇಲ್ಲಿ ವಾಟರ್ ಅಂತ ಅಷ್ಟೇ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ, ಅಂದ್ರೆ ನೀರು ಇರುತ್ತೆ. ಇವಾಗ ಎರಡನೇ ಚಿತ್ರದಲ್ಲಿ ನೀವು ಅದಕ್ಕೆ ಶಾಖವನ್ನ ಕೊಟ್ಟಾಗ ಇಲ್ಲಿ ನೀರೇನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇದು TS ಅಂತ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ, ಅಂದ್ರೆ ಸ್ಯಾಚುರೇಷನ್ ಟೆಂಪರೇಚರ್ ರೀಚ್ ಆಗುತ್ತೆ. ಸ್ಯಾಚುರೇಷನ್ ಟೆಂಪರೇಚರ್ ಅಂತ ಅಂದ್ರೆ 100 degrees Celsius. It is the temperature at which water starts boiling. ಯಾವಾಗ ನೀರು ಕುದಿಯುವ ಹಂತಕ್ಕೆ ತಲುಪುತ್ತೋ ಆ ಒಂದು ಹಂತದಲ್ಲಿ ಏನು ಉಷ್ಣತೆ ಇರುತ್ತೋ ಆ ಉಷ್ಣತೆಗೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ಸ್ಯಾಚುರೇಷನ್ ಟೆಂಪರೇಚರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಆ ಒಂದು ಇದು ಏನಿರುತ್ತೆ ಇಲ್ಲಿ ಎರಡನೇ ಚಿತ್ರದಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. ಆವಾಗ ಇನ್ನೂ ನೀವು ಹಾಗೆ ಶಾಖವನ್ನ ಅದಕ್ಕೆ ನೀಡ್ತಾ ಹೋದ್ರೆ ಅದು ಒಂದು ಕುದಿಯುವ ಹಂತವನ್ನ ತಲುಪಿದ ಮೇಲೆಯೂ ಅದಕ್ಕೆ ನೀವು ಶಾಖವನ್ನ ಅದಕ್ಕೆ ನೀಡ್ತಾ ಹೋದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಅದು ಆವಿಯಾಗ್ತಾ ಹೋಗುತ್ತೆ. ಅವಾಗ ಆವಿ ಆಗುತ್ತೆ. ಅವಾಗ ಮೂರನೇ ಚಿತ್ರದಲ್ಲಿ ಇಲ್ಲಿ ವೆಟ್ ಸ್ಟೀಮ್ ಮತ್ತು ವಾಟರ್ ಎರಡೂ ತೋರಿಸ್ತಾ ಇದ್ದೇನೆ. ಸೊ ಎರಡು ತೋರಿಸ್ತಾ ಇದ್ದೇನೆ ಅಂತಂದ್ರೆ ಮೇಲೆ ಇರತಕ್ಕಂತಹ ಇದು ಆವಿ ಏನಿದೆ ಅಲ್ಲಿ ವೆಟ್ ಸ್ಟೀಮ್ ಅಂತ ಇದೆ. ವೆಟ್ ಸ್ಟೀಮ್, ವೆಟ್ ಅಂದ್ರೆ ತಂಬಳ ನಾವು ಕರಿತಾ ಇರೋದು. ಸೊ ಅದಕ್ಕೆ ಇಲ್ಲಿ ಆ ಸ್ಟೀಮಿನ ಜೊತೆಗೆ ಆವಿಯ ಜೊತೆಗೆ ಸ್ವಲ್ಪ ನೀರಿನ ಕಣಗಳ ಇರ್ತದೆ, ನೀರಿನ ಕಣಗಳಿರ್ತವೆ. ಸೊ ಅಂತಹ ಒಂದು ಆವಿಗೆ, ಅಂತಹ ಒಂದು ಉಗಿಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ ಅಂತಂದ್ರೆ ವೆಟ್ ಸ್ಟೀಮ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಯಾವಾಗ ನಾಲ್ಕನೇ ಚಿತ್ರದಲ್ಲಿ ಬಂದಾಗ ಈ ಒಂದು ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಮೇಲೆ ಸ್ವಲ್ಪ ವೆಟ್ ಸ್ಟೀಮು, ಕೆಳಗಡೆ ಇನ್ನೂ ಸ್ವಲ್ಪ ನೀರಿರುತ್ತೆ. ಇನ್ನು ಮತ್ತೆ ನೀವು ಶಾಖವನ್ನು ಅದಕ್ಕೆ ಕೊಡ್ತಾ ಹೋಗಿ, ಶಾಖವನ್ನು ನೀವು ಕೊಡ್ತಾ ಹೋದಾಗ ಅವಾಗ ಎಲ್ಲ ನೀರು ಕೂಡ ಏನಾಗುತ್ತೆ, ಉಗಿಯಾಗಿ ಬದಲಾವಣೆ ಹೊಂದುತ್ತೆ. ಯಾವಾಗ ಅದು ಉಗಿಯಾಗಿ ಬದಲಾವಣೆಯನ್ನು ಹೊಂದಿತೋ ಅವಾಗ ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಡ್ರೈ ಸ್ಯಾಚುರೇಟೆಡ್ ಸ್ಟೀಮ್ ಅಂತ ಕರಿತೀವಿ. ಅವಾಗ ಅಲ್ಲಿ ನೀರಿನ ಕಣಗಳು ಇರೋದಿಲ್ಲ, ಅಲ್ಲಿ ಇರೋದು ಎಲ್ಲ ಉಗಿಯಾಗಿರುತ್ತೆ, ಅದು ಸ್ಟೀಮ್ ಆಗಿರುತ್ತೆ. ಸೊ ಆದ್ರೂ ಕೂಡ ಮತ್ತೆ ನೀವು ಅದಕ್ಕೆ ಶಾಖವನ್ನ ನೀಡ್ತಾ ಹೋದಾಗ ಅದೇನಾಗುತ್ತೆ, ಅವಾಗ ಸೂಪರ್ ಹೀಟೆಡ್ ಸ್ಟೀಮ್ ಆಗಿ ಬದಲಾವಣೆಯನ್ನ ಹೊಂದುತ್ತೆ. ಯಾವಾಗ ಸೂಪರ್ ಹೀಟೆಡ್ ಸ್ಟೀಮ್ ಆಗಿ ಅದು ಬದಲಾವಣೆ ಹೊಂದಿತೋ ಆವಾಗ ಅದು ಎಲ್ಲ ಆ ಗ್ಯಾಸ್ ಲಾಸ್ ಅನ್ನು ಫಾಲೋ ಮಾಡುತ್ತೆ. ಇಟ್ ಒಬೇಸ್ ಆಲ್ ದ ಗ್ಯಾಸ್ ಲಾಸ್ when it is super saturated steam at the stage 5. ಈ ಒಂದು 5 ಸಿಲಿಂಡರ್ ಅಲ್ಲಿ ಆಗತಕ್ಕಂತ ಬದಲಾವಣೆಯನ್ನ ನಾನು ಏನು ನಿಮಗೆ ಹೇಳ್ತಾ ಇದ್ದೀನೋ ಅದೇ ಬದಲಾವಣೆಯನ್ನ ಈ ಒಂದು ಈ ಒಂದು ಬಲಭಾಗದಲ್ಲಿರ್ತಕ್ಕಂಥ ಚಿತ್ರದಲ್ಲಿ ಕೂಡ ನಾವು ಹೀಟ್ ಮತ್ತು ಟೆಂಪರೇಚರ್, ಶಾಖ ಮತ್ತು ಉಷ್ಣತೆಯ ಒಂದು ಗ್ರಾಫ್ ನಲ್ಲಿ ನಾನು ತೋರಿಸ್ತಾ ಇದ್ದೇನೆ. ಈ ಉಷ್ಣತೆ ಅಂದ್ರೆ ಶಾಖನ ನೀವು ಏನ್ ಕೊಡ್ತಾ ಇದ್ರು ಅದನ್ನ ನಾವು heat ಅಂತ ಕರಿತೀವಿ. On x-axis there is a heat, on the y-axis there is a temperature. So here in the x-axis there is a heat is there. So I have represented it by small h. So in the previous semester I told you small h is used to represent the enthalpy. So enthalpy means it is the amount of heat supplied to a system at constant pressure. At constant pressure we call it as enthalpy. In this case also we are maintaining the pressure constant. So and we are supplying heat to the system. Cylinder is a system where this is the cylinder piston arrangement we call is a system here, right? For this system I am supplying heat and also maintaining the pressure constant. So the whatever the amount of heat you are supplying, so that is called as enthalpy here. So ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿ AB sensible heat, that is AB means ಈ A ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾವು ನೀರನ್ನ ತಗೊಂಡಿರ್ತೀವಿ. ನೀವು ಇದಕ್ಕೆ ಹೀಟ್ ಅನ್ನ ಶಾಖವನ್ನ ನೀಡ್ತಾ ಹೋದಾಗ ಅದು ಏನಾಗುತ್ತೆ, ಇನಿಷಿಯಲಿ ಇಟ್ ಈಸ್ ಲೀನಿಯರ್ಲಿ ಪ್ರೊಪೋರ್ಷನಲ್ ಅಂಡ್ ಇಟ್ ರೀಚಸ್ ಪಾಯಿಂಟ್ B. So at point A, the temperature is 0 degrees Celsius, and at point B, the temperature is 100 degrees Celsius. Remember, the pressure is atmospheric pressure. ಯಾವಾಗ ನೀವು ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಆ ನೀರಿಗೆ ನೀವು ಶಾಖವನ್ನ ನೀಡ್ತಾ ಹೋಗ್ತೀರೋ ಆ ಸಂದರ್ಭದಲ್ಲಿ ಮಾತ್ರ ಎ ಅನ್ನೋದು 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇರುತ್ತೆ, ಬಿ ಅನ್ನೋದು 100 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇರುತ್ತೆ. ಬಟ್ ಪ್ರೆಷರ್ ಚೇಂಜ್ ಆಯ್ತಂದ್ರೆ, ಪ್ರೆಷರ್ ಅನ್ನ ನೀವು ಬದಲಾವಣೆ ಮಾಡಿದರೆ ಅವಾಗ ಈ ಬಿ ಅಂತಕ್ಕಂತಹ ಉಷ್ಣತೆ ಬದಲಾವಣೆ ಹೊಂದುತ್ತೆ. ಅದನ್ನೇ ನಾವು ಈ ಒಂದು ಸೆಷನ್ ಅಲ್ಲಿ ಮುಂದೆ ನೋಡ್ತೀವಿ. ಯಾವಾಗ ಪ್ರೆಷರ್ ಅನ್ನ ಬದಲಾವಣೆ ಮಾಡಿದಾಗ ಟೆಂಪರೇಚರ್ ಯಾವ ರೀತಿಯಾಗಿ ಬದಲಾವಣೆ ಹೊಂದುತ್ತೆ ಅನ್ನೋದನ್ನ ಕೂಡ ನಾವು ಮುಂದೆ ನೋಡ್ತೀವಿ. ಸೊ ಈಗ ಈ ಬಿ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ವಾಟರ್ ಬಾಯ್ಲಿಂಗ್. ಹಿಯರ್ ಅಟ್ ಬಿ ಪಾಯಿಂಟ್ ವಾಟರ್ ಸ್ಟಾರ್ಟ್ಸ್ ಬಾಯ್ಲಿಂಗ್. ಸೊ ದಟ್ ಟೆಂಪರೇಚರ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಸ್ಯಾಚುರೇಷನ್ ಟೆಂಪರೇಚರ್. Saturation temperature, and it is represented by Ts. So here this I have shown it the horizontal line from B to C. This is called as the B to C. It is a wet steam. It is wet steam, latent heat of evaporation. The temperature remains the same here. So at atmospheric pressure, the temperature remains 100 degrees Celsius, and the water starts converting to the steam. Still there is some amount of water molecules are present in the stream. ಸೊ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂದ್ರೆ ನೀರಿನ ಹನಿಗಳು ಈ ಉಗಿಯ ಜೊತೆ ಇರ್ತವೆ. ಎಲ್ಲಿರ್ತವೆ ಅಂತಂದ್ರೆ ಫ್ರಮ್ ಬಿ ಟು ಸಿ ಲೈನ್ ಅಲ್ಲಿ, ಬಿ ಟು ಸಿ ನಲ್ಲಿ ಬಿ ಟು ಸಿ ಹೋಗೋದ್ರ ದಾರಿಯ ಮಧ್ಯದಲ್ಲಿ ನೀವು ಕೆಲವೊಂದಿಷ್ಟು ನೀರಿನ ಹನಿಗಳನ್ನ ಕೂಡ ಉಗಿಯ ಜೊತೆ ನೀವು ಕಾಣ್ತೀರಿ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ವೆಟ್ ಸ್ಟೀಮ್. ವೆಟ್ ಸ್ಟೀಮ್ ಅಂತಂದ್ರೆ ಉಗಿಯ ಜೊತೆಯಲ್ಲಿ ನೀರಿನ ಹನಿಗಳು ಇದ್ದರೆ ಅದಕ್ಕೆ ನಾವು ವೆಟ್ ಸ್ಟೀಮ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಅಂತಹ ಒಂದು ವೆಟ್ ಸ್ಟೀಮ್ಗೆ ನೀವು ಕನ್ವರ್ಷನ್ ಮಾಡಾಗ ಏನ್ ಅಮೌಂಟ್ ನೀವು ಅದಕ್ಕೆ ಶಾಖವನ್ನ ನೀಡ್ತಿರೋ ಆ ಒಂದು ಶಾಖಿಗೆ ನಾವು ಲೆಟೆಂಟ್ ಹೀಟ್ ಆಫ್ ಎವಾಪರೇಷನ್ ಅಂತ ಕರಿತೇವೆ. ಯಾವಾಗ ಇದು ಪಾಯಿಂಟ್ ಸಿ ಗೆ ಬಂದು ತಲುಪುತ್ತೋ ಆ ಒಂದು ಸಿ ಪಾಯಿಂಟ್ಗೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ಡ್ರೈ ಸ್ಟೀಮ್ ಅಂತ ಕರಿತೇವೆ. ಫ್ರಮ್ ಬಿ ದಿಂದ ಪ್ರಾರಂಭವಾಗಿ ಈ ಮಧ್ಯದಲ್ಲಿ ಎಲ್ಲಾದ್ರೂ ನೀವು ತಗೊಂಡ್ರೆ ಇದು ಎಲ್ಲಾನು ಏನಿರುತ್ತೆ, ವೆಟ್ ಸ್ಟೀಮ್ ಇರುತ್ತೆ. ವೆಟ್ ಸ್ಟೀಮ್ ಇರುತ್ತೆ. ಯಾವಾಗ ಸಿ ಪಾಯಿಂಟ್ ಅನ್ನ ಅದು ತಲುಪುತ್ತೋ ಸಿ ಪಾಯಿಂಟ್ ಗೆ ಮಾತ್ರ ಇದು ಏನಾಗುತ್ತೆ, ಡ್ರೈ ಸ್ಟೀಮ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿರುತ್ತೆ. ಅಲ್ಲಿ ನೀರಿನ ಹನಿಗಳು ಉಗಿಯ ಜೊತೆ ಇರೋದಿಲ್ಲ. ಸೊ ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ನೀವು ಅದಕ್ಕೆ ಶಾಖವನ್ನ ನೀಡ್ತಾ ಹೋದಾಗ ಅದೇನಾಗುತ್ತೆ, ಮತ್ತೆ ಇಟ್ ರೀಚಸ್ ದ ಪಾಯಿಂಟ್ ಡಿ. And from C to D, so the steam is super saturated steam. Super saturated steam, then it behaves like a pure substance and it is an idle gas, and there it obeys all Hooke's laws. So ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿ ಬಂದಾಗ HF ಅಂತ ಕೊಡ್ತಾ ಇದ್ದೀನಿ. HF ಅಂತಂದ್ರೆ this is a sensible heat. Sensible heat means the total amount of heat supplied. ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಅನ್ನು ನೀವು ಸಪ್ಲೈ ಮಾಡಿದ್ರು ಸೊ ವಾಟರ್ ಇಂದ ಕನ್ವರ್ಟ್ ಆಗಕ್ಕೆ ಅದು ಸೆನ್ಸಿಬಲ್ ಹೀಟ್. ಸೊ ಇದು ಎಲ್ಲ ನಾವು ಸೆನ್ಸಿಬಲ್ ಹೀಟ್ ಅಂದ್ರೆ ಏನು, ಲೆಟೆಂಟ್ ಹೀಟ್ ಆಫ್ ಆಪರೇಷನ್ ಅಂದ್ರೆ ಏನು, ಹೀಟ್ ಆಫ್ ಸೂಪರ್ ಹೀಟ್ ಅಂದ್ರೆ ಏನು, ನಾವು ಮುಂದಿನ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ನೋಡೋಣ. ಸೊ ನಾವು ವಿಲ್ ಸಿ ಎಫೆಕ್ಟ್ ಆಫ್ ಪ್ರೆಷರ್ ಆನ್ ಸ್ಟೀಮ್ ಫಾರ್ಮೇಶನ್. In the previous slide we have seen the formation of steam under constant pressure. So now if you not maintain the pressure constant, so what is the effect of that on the steam formation? So effect of that on the steam formation means what are the how the properties are going to change when the pressure changes. So in this figure, so in the previous slide we have seen only from A to B, then B to C and C to D. This is the only line it was there in the formation of steam at constant pressure. But now I have shown, so there are n number of curves like this. There is a family of curves we arrive when we change the pressures. Now it is a P pressure and P1, and P2. So now if the pressure changes from P to P1 and from P1 to P2, so I'm changing the pressure. If the pressure changes from P to P1, then what happens now? The point E, the point E, the point B, what we call the point B, it is called as a saturation temperature point. This saturation temperature point shifts from B to E when the pressure changes from P to P1. So it means when the pressure is atmospheric pressure, the saturation temperature is 100 degrees Celsius. When the pressure changes from P to P1, the temperature is more than the 100 degrees Celsius. So it means when the pressure changes, even temperature increases. It means the saturation temperature keeps on increasing when you change the pressures. So when you change pressure from P1 to P2, again the point E shifts from E to K. It shifts from E to K. So like that, the point keeps on shifting when you change the pressures. So now here in this case, in the second, when pressure changes from P to P1, the E of line is called as latent heat of evaporation. Means the latent heat of evaporation keeps on decreasing when you change the pressure. The line FG is called as formation of superheated steam. Right? So when the pressure changes from P1 to P2, like that, when it changes from P2 to P3, certain point, both the temperature and pressure meets at a point. So that point we call it as N. That is called as a critical point. This N is called as a critical point. Now the line passing through A, B, E and K. The line passing through A, B, E and K is known as saturated liquid line. It is called as saturated liquid line, or simply it is a liquid line. So the line separates, or I can say, so this line ABEK line, or it is a curve. So it behaves like a boundary between the water and wet steam. So from this line, so whatever I've shown, this ABEK line, from this line on this side is water, and from this side up to this it is wet steam. So this is the water and this is the wet steam. So water and wet steam. So now, so again there is a one more line from CFL. CFL, this line we call it as dry saturated steam line, or simply dry steam line. It is called as dry steam line. So this also behaves like a boundary, and it separates wet steam with respect to the super saturated steam. From this line, left hand side is a wet steam, on the right hand side it is a super saturated steam. So there is two lines you need to remember. One line is liquid line and one more line is dry steam line. Liquid line separates water and wet steam, and a dry steam line separates wet steam and superheated steam. Now we'll see what is the critical pressure and critical temperature. So right, so this one I have explained in the previous slide. What is the critical point when you keeps on changing the pressure? So from P1, P2 like that, at a certain point of time, so it becomes a zero at point N, where liquid line and dry steam lines meet. So the liquid line and the dry steam lines both meets at this point, and this point we call it as the critical point. The temperature corresponding to this point is called as critical temperature, and the pressure corresponding to this point is called as the critical pressure. For steam, the critical temperature is 374.15 degrees Celsius, and the critical pressure is 221.2 bars. So now we will see the properties of steam. First one is dryness fraction or quality of steam. Dryness fraction or quality of steam. Dryness fraction. So this dryness fraction comes for wet steam. If it is a wet steam, I told you wet steam means so the steam where the certain amount of water molecules are present. So that is called as a wet steam. So the dryness fraction is defined as it is the ratio of mass of dry steam present in wet steam to the total mass of wet steam. So in the wet steam, there is some amount of water molecules are present. So the total amount of dry steam present in wet steam. Wet steam means it is a combination of some amount of dry steam and some amount of water molecules are present. So the mass of dry steam present in wet steam to the total mass of wet steam. This is the ratio, we call it as a dryness fraction. So this is represented by x. So this x is equal to mg. So to the mf plus mg. So this is equal to mg divided by m. M means is the total mass of the wet steam. Mf is the mass of the water molecules and this is the mass of the dry steam. So if you combine both, you will get the total mass of the wet steam, and mg is the mass of the dry steam. So mg by m will give you the dryness fraction. The next wetness fraction. So wetness fraction means it is a reverse of the dryness fraction. In the numerator we have considered it is the mass of the dry steam here mg, but in the case of wet fraction we are considering at the top it is the mf, means total mass of suspended water particles present in the wet steam. But in the dryness fraction it's a dry steam we have considered. So in the wetness fraction you have to consider the suspended water molecules, that is mass of the suspended water molecules present in the wet steam to the total mass of the wet steam. So this is also given by mf by mf plus mg again. So this is equal to mf by m. So the ratios remain same, but only there is a change in the numerators. Dryness fraction and wetness fractions, there is only change in the numerators. In the dryness fraction, here the dryness will come. So mg, the dry steam present in the wet steam, mg. So here it is mf, there is a mass of suspended water particles present in wet steam to the total mass of the wet steam. So to define this once again, so the wetness fraction is defined as it is the ratio of mass of suspended water particles present in wet steam to the total mass of the wet steam. So next one is sensible heat or liquid heat or a total heat of water. So this one I've shown it while explaining the formation of a steam under constant pressure. So initial point, so where the steam formation takes place from the point A to B. So the total amount of heat what you are supplying from the point A to B, so that we call it as a sensible heat or liquid heat or total heat of water. So it is defined as it is the amount of heat absorbed by 1 kg of water when heated at a constant pressure from the freezing point, that is 0 degrees Celsius, to the saturation temperature Ts. Freezing point means it is a freezing temperature from 0 degrees Celsius. It has to reach the Ts. Ts is boiling temperature or saturation temperature. Boiling temperature or saturation temperature. So from 0 degrees Celsius you have to boil, you need to supply the amount of heat to it. It reaches up to 100 degrees Celsius. The freezing point is 0 degrees Celsius and the boiling point is 100 degrees Celsius. Remember that pressure is atmospheric pressure. So this holds good only when the pressure is atmospheric, then only the amount of heat supplied from the 0 degrees Celsius to the the saturation temperature, that is 100 degrees Celsius, is called as sensible heat. So, and it is given by the formula HF is equal to mass into specific heat into rise in temperature. So this is given by M into CW into delta T. M is mass of the water, CW is specific heat of the water, delta T is a change in the temperature. So right, so in this case we have considered M as unit mass, that is 1 kg of water. So this becomes 1 and CW and delta T. So after substituting these values, delta T you know already, after substituting this, then the specific heat of water, is 4.2 kilojoules per kg. So this you can substitute, then you will get the sensible heat or liquid heat or total heat of water. Next one, latent heat of vaporization or enthalpy of evaporation. Both are same. Latent, remember sensible heat HF, it's very important while doing the formula. So in the problems he will ask to find out the sensible heat, latent heat of vaporization and superheat. So these three terms he is going to ask: enthalpy of evaporation, enthalpy of the liquid heat or total heat, then he will ask the enthalpy of superheated steam. So these three formulas are very important while solving the problem. So next, latent heat of vaporization. So it is the amount of heat required to completely convert 1 kg of water at saturation temperature, that is Ts, into 1 kg of dry steam at the same saturation temperature Ts. You have to maintain the same saturation temperature. In this case, if the pressure is atmospheric, the saturation temperature is 100 degrees Celsius. At 100 degrees Celsius, the steam must convert from the wet steam to the dry steam. How much amount of heat you are supplying to the wet steam to get it converted to dry steam at 100 degrees Celsius only, maintaining the Ts the same. So that amount of heat you supply to it, that amount of heat we call it as latent heat of vaporization or enthalpy of evaporation, and that is represented by HFG. The next, heat of superheat. Heat of superheat means after dry saturated steam, you keeps on supplying heat again, then again it gets converted into a superheated steam. It is the amount of heat required to convert 1 kg of dry saturated steam at saturation temperature into 1 kg of superheated steam of required temperature T soup. It means when the steam is dry steam, so in the previous you have studied latent heat of vaporization. So latent heat of evaporation means converting wet steam to dry steam, maintaining the temperature 100 degrees Celsius. The total amount of heat supplied to it is called as the latent heat of evaporation. But in this case, at Ts temperature, the steam is dry saturated steam. So again you supply some amount of heat. So when you supply some amount of heat, that dry steam gets converted into a superheated steam. So when it converts into a superheated steam, at that time the temperature would be T soup. It is greater than the saturation temperature. So at that time, the whatever amount of heat you supplied, so that is called as heat of superheat, and it is calculated by using the formula M into CPS, is the specific heat of superheated steam, into the change in temperature. Again, here change in temperature gives you the T soup minus Ts. So this is equal to CPS T soup minus Ts, because M we consider here as 1 kg unit mass. The next one, enthalpy or total heat of steam. enthalpy or total heat of steam. Enthalpy, the word comes enthalpy. Why the enthalpy? Enthalpy means the amount of heat supplied to a system when the pressure is constant. The maintaining the pressure constant, the whatever amount of heat you are supplying to the system, so that heat we call it as enthalpy or total heat of steam H, right? So again, remember, so this is very important for the problem point of view. When you start solving the problem, so this is very important. So it is the amount of heat supplied at constant pressure. So I told you it is the amount of heat supplied at constant pressure to convert 1 kg of water at 0 degrees Celsius into specified type of steam. So the enthalpy or total heat of steam is equal to sensible heat plus latent heat. So when you combine both, so that will give you total heat of steam, right? So the H is equal to HF plus HFG. HF means, so the amount of HF means the amount of heat supplied to a water when it gets converted from water to the saturation temperature, that is HF. HFG means it is the amount of heat supplied from saturation temperature to a dry saturated steam. Maintaining same, the temperature Ts remains the same, but it should convert from wet steam to the dry steam. So for that, how much amount of heat you are supplying, so that is called as HFG. When you combine both, so this is the sensible heat and this is the latent heat of evaporation. When you combine both, that will give you the total heat of steam or the total enthalpy of steam formation. So in this we'll see first one, enthalpy of wet steam. So this is very important, enthalpy of wet steam. So he will ask in the problem to find out the enthalpy of wet steam, so by giving the dryness fraction. So whenever the dryness fraction is mentioned, then remember it is wet steam, right? So here it is enthalpy of wet steam. Wet steam means, so it is the combination of the water molecules the present in the steam. So H wet is equal to HF plus XHFG. XHFG, wet steam. I have shown the drawing something like this, So this is point A and this is point B and this is a point C. From B to C it is called as a latent heat of evaporation. From B to C you take anywhere the point, so at all the points it is wet steam. When it reaches C, then it becomes dry saturated steam. So at each point between B and C it is wet steam. So first one is HF. HF means it is a amount of heat supplied to increase the temperature from 0 degrees Celsius to a saturation temperature, means from A to B, whatever amount of heat you are supplying, that is called as HF. Plus XHFG is saying XHFG means wet steam. Wet steam means from B to C it is a wet steam. So in that case, so you need to find out the amount of heat is applied for this wet steam. So that is called as enthalpy of wet steam. Here X comes, so how much the fraction the steam is wet. So that fraction if you multiplied with the amount of heat supplied, so it will give you the enthalpy of wet steam. Next, second one, enthalpy of dry steam. It is represented by H dry or Hg. So Hg means the steam is dry at the point C. So at the point C, the amount of heat you are supplying, so that is called as the dry steam. That is enthalpy of dry steam. Enthalpy of dry steam. Once again, I'll show it here like this. So this is a B point. From this B point to this C point, when it reaches the point C, this is called as dry saturated steam. So at point A, so at point A means initially here at point A, it starts with at point A. From point A to B, this is the sensible heat. From B to C, it is the latent heat of evaporation. So this is called as HF, this is HF, and this is HFG. This is HFG. So if you add both this and this, will give the H dry, that is enthalpy of dry steam. So enthalpy of dry steam means addition of the sensible heat plus heat of evaporation. If at the point C, if you ask to find out the dry steam, directly you can add these two values. These two values you will get it from the steam table. So I will tell you in the future sessions how to refer steam tables and all. But when if we ask you to find out the steam enthalpy at this point, if you say this is the point, at this point means the steam is wet. So in such case, the formula it is H wet, and there is only one term comes extra, that is called as X. This is dryness fraction. So this is a previous formula. So the next third one is enthalpy of superheated steam. Enthalpy of superheated steam means it is from C to D point. So from C to D point, we call it as enthalpy of superheated steam. From it has to cross the sensible heat, latent heat of evaporation, then it has to become superheated steam. It means it is addition of HF plus HFG, then some amount of heat in this region. Right? So because of that, the formula is H superheated H soup is equal to HF plus HFG. So these two terms will give you dry saturated steam. Once it reaches dry saturated steam, then only it will move to the super saturated steam. So this is plus CPS T soup minus TS. This is called sensible heat, latent heat, and this is heat of superheat. So if you add all the three, that will give you enthalpy of superheated steam. Then what is the degree of superheat? Degree of superheat is T soup minus Ts. T soup means the highest temperature at the superheated steam minus Ts will give you the degree of superheat. And seventh, specific volume of steam. What is the specific volume of steam now? That is meter cube per kg. That's the volume. So as I told you, whenever you supply the heat, temperature increases, the pressure also increases, but the condition is that you need to maintain the pressure constant. When you maintain the pressure constant, then definitely the volume increases. So that volume we need to calculate, that is specific volume of steam. It is the volume occupied by unit mass of steam at a given temperature and pressure. Right? It decreases with increase in pressure. If the pressure increases, then volume decreases. Right? Pressure increases, the volume decreases. So this you need to remember. So next one is specific volume of wet steam. So what is the specific volume of wet steam? So it is the volume occupied by unit mass of wet steam at the saturation temperature for the given pressure. So it is the volume occupied by the wet steam. So how the volume is occupied? So let us consider, I will explain in detail. Consider 1 kg of wet steam of dryness fraction X. It means you consider 1 kg of wet mass. 1 kg of wet mass means this wet steam consists of some amount of dry steam as well as some amount of water particles present in the steam. So it means it has some dryness fraction X. It has some dryness fraction means definitely the steam is with some water droplets or water molecules. So this means that given wet steam contains X kg of dry steam, X kg of dry steam if it is present, then 1 minus X kg of water is present in the steam. ಸೊ ಯಾವಾಗ ಎಕ್ಸ್ ಕೆ ಜಿ ಡ್ರೈ ಸ್ಟೀಮ್ ಇರುತ್ತೋ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಡ್ರೈ ಸ್ಟೀಮ್ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ 1 minus x kg of water ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ಇನ್ ಮಿಕ್ಸ್ಚರ್ ವಿತ್ ದಿ ಡ್ರೈ ಸ್ಟೀಮ್. So let Vf is volume of 1 kg of water, then Vg is equal to volume of 1 kg of dry steam. So now I'll consider Vf as volume of 1 kg of water. Vg I'll consider volume of 1 kg of dry steam. Then volume of 1 kg of wet steam is given by V wet is equal to x into Vg plus 1 minus x into Vf. So as I said, x is a dryness fraction. If you multiply this x with Vg, this is a specific volume of dry steam. Then 1 minus x is the volume of wet steam. This you multiply with specific volume of wet steam. Since Vf is very small as compared to Vg, therefore the expression 1 minus x into V of be neglected. So this is very small. So then you need to neglect this. So the volume of 1 kg of wet steam V wet is equal to x into Vg. This is the important formula you should remember. The specific volume of wet steam is x into Vg, where x is the dryness fraction. Similarly, specific volume of dry steam now. So if it is a dry steam, then what is the specific volume? So this is so V dry is equal to Vg. So volume of dry steam is equal to, so the same, it is given by directly Vg. So these values you will get it directly from the steam tables. So sometimes you will give you the values of this specific volume in the problem, or you can refer the steam table and you can directly get these values from the steam table. Then specific volume of superheated steam. So you need to find out the specific volume of superheated steam. So when the steam becomes superheated, I told you this is a real gas. So there is the ideal gas. Then it follows the gas laws. So both dry steam and superheated steam behaves like perfect gas. So dry steam means at point C, it behaves like perfect gas. Therefore, so all the gas laws applies. Now we are going to calculate only the specific volume, and the temperature we know. The temperature also varies here and volume also varies here, but keeping the pressure constant. Keeping the pressure constant, and what is the relation between volume and temperature? So that relation is given by the Charles law. So according to the Charles law, so V sub by T sub is equal to this is a Vg, the specific volume of a dry steam, to the saturation temperature. So V sub is equal to, this becomes cross multiplication here. So V sub, so keeping on the left hand side, Vg by Ts as it is, into T sub, it will come from the bottom to the right side. So V sub you will calculate by using this equation from the Charles law. So now we'll see some multiple choice questions on the topics covered in the session 2. So what is the effect of increase of pressure on the enthalpy of steam? So here A increases, B decreases, C remains the same, so D is none. So answer is B, so it is decreases. Then dryness fraction of steam is equal to, dryness fraction of steam is equal to, so A is mW by mW plus mg, B is mg by mw plus mg, C is mw plus mg by mg, and none. So the solution is B. The B is mg by mw plus mg. You know this. So I have explained, this is the dryness fraction. Then effect of increase of pressure on the specific volume of water is increases, decreases, remains the same, none. So the solution is C, that is remains the same. Then dryness fraction of superheated steam is equal to 1, less than 1, greater than 1, none. Dryness fraction of superheated steam. So dryness fraction of superheated steam is more, it's equal to 1. Then only we can say that the superheated steam. So it is 1. So the solution is A. Then enthalpy of saturated steam is, enthalpy of saturated steam is equal to the enthalpy of wet steam, less than the enthalpy of wet steam, greater than the enthalpy of wet steam, none. The answer is C, that is greater than the enthalpy of wet steam. Thank you.